Good afternoon, Tech Nation. Thank you all for participating in today's webinar. We are thrilled with a great turnout today with over 375 attendees registered. Just a few notes before we begin today. Earlier, registrants were emailed a Webinar Wednesday workbook. If you did not receive the book, you can download a copy in the handout section on your webinar dashboard. All lines will be muted today, but you can submit questions by using the questions or chat feature on your dashboard. Today's webinar is eligible for 0.1 CE credits from the ICC. Certificates of attendance are sent to attendees that complete the post-webinar survey at the conclusion of today's webinar. The survey will appear on your computer screen, and certificates will be emailed on or before October 8th. If you do not receive the survey, please email us at webinar@mdpublishing.com. Don't forget, many of the same speakers from our Webinar Wednesday series are featured at our annual trade shows. Our next trade show is coming up, MD Expo 2015 Las Vegas. That's going to be held October 21 to the 23rd at Red Rock Resort. A complimentary VIP pass for hospital employees, military, and students was provided in today's webinar workbook. You can always register for the event by visiting mdexposhow.com. TechNation would like to thank our sponsor today, Daytrend Systems. Daytrend provides the biomedical engineering community with a comprehensive line of quality test instruments. Daytrend is committed to developing innovations that make our test equipment easier to use and more effective. For more information on Daytrend Systems, visit www.daytrend.com. All right, our presenter today is Mark Miller, a registered professional engineer and vice president of engineering at Daytrend Systems. Mark has more than 20 years of experience designing and developing specialized instrumentation and software for medical equipment maintenance and testing. Mark, you can begin whenever you're ready.
Okay, thanks very much, John. And thanks, everybody, for tuning in. Listen to me talk about medical equipment maintenance and some new technology. It's being used to save time, money, and manpower with computer-based automation. Accreditation agencies are now enforcing new regulations, and the potential impact of these regulations on maintenance practice needs to be considered. I'm going to be referring to these regulations throughout my talk, so I want to start with those first. The regulations refer to maintenance activities, and that means preventive, corrective maintenance, and incoming inspection. I'm going to break down those activities, and I'll show where and how task automation fits in the workflow. To do that, I'm going to need to cover computerized maintenance management systems, but I don't want to focus too much on that. The main topic of today's presentation is automation of PM inspection and test and how it works on a practical level. The Centers for Medicare and Medicaid Services is an essential source of funding for a vast majority of U.S. hospitals. Its authority comes from federal law, which sets conditions for participation in the funding. In particular, there's requirements for facilities and equipment to be maintained to ensure safety and quality for patients and staff. In 2013, CMMS issued a survey and certification, or S&C memo, that changed guidelines used by surveyors to determine whether or not a hospital would receive funding. I summarized some points from that memo here. Hospitals are now required to create an inventory of all equipment, regardless of risk or asset value. Critical devices, for which there's a significant risk of injury or death in the event of a failure, need to be explicitly identified in the inventory. Maintenance requirements for each device, critical and non-critical, need to be documented. The regulation requires performance and safety of every device to be tested before the initial use and after major repair or upgrade. CMMS says the hospitals comply with this regulation when they follow manufacturer's maintenance procedures and frequencies. However, an alternative equipment management, or AEM program, is allowed, where a hospital can use its own maintenance procedures and schedules for some devices, provided certain conditions are met. To place a device on alternative equipment management, a documented risk analysis for that device needs to be performed. You have to consider the use, hazards, failure modes, and a past service history. As with the critical devices, a device which is under AEM needs to be explicitly identified in the inventory. certain types of equipment are exempt from AEM. For these, you must follow the manufacturer's maintenance procedure and schedule. This includes imaging equipment, medical lasers, and new equipment for which you don't have a service history. The AEM program needs to be periodically evaluated to show it doesn't adversely affect device safety or effectiveness. The underlying concept here is one of continual improvement, which is seen in quality systems like ISO and FDA GMP. The evolution of this regulation along the lines of quality system principles is a topic I'll be coming back to later. This last point on the list is one of immediate concern to technicians and their managers. The regulation is very clear that AEM procedures and schedules must be strictly followed. Joint Commission is an accreditation agency for hospitals in the U.S. It and other accreditors get their authority from the CMMS, and they survey compliance to the S&C memo. Under previous versions of TJC standard, an audit score would depend on meeting targets that were defined in a Medical Equipment Management Plan, or MEMP. Back then, a plan was expected to set targets of 100% PM completion on life support and 95% or higher for non-life support. The auditor's score then depended on the hospital meeting those targets. The current regulation expands the definition of critical equipment to encompass life support and many other devices. The CMMS memo instructs surveyors to focus on the critical equipment in the inventory. In the memo, the language strictly follow with respect to frequencies implies that an auditor's score will likely depend on achieving 100% PM completion for these critical devices. The effect of S&C 1407 is that for some hospitals, the size of their inventory is going to increase. The asset value doesn't matter, nor the practicality of assigning resources to maintain relatively low-cost devices if there's a risk of misdiagnosis causing harm. Some have suggested good ideas for dealing with these kind of devices. For example, you can group lots under a single control number in the inventory. Regardless, these kind of devices must have a maintenance strategy, and so they will consume some part of the labor resource in the CE department. Labor has become a precious resource these days. In its HDM salary survey, the trade journal 24/7 has received essentially the same response with respect to workload for 2 years running. Fully 2/3 of a significant number of respondents feel their workload is unreasonable, ranging from heavy to excessive. Wow. So according to the magazine, if we saw 1,000 techs doing departmental sweeps in their hospitals today, over 600 of them might look like this guy saying, how the heck am I going to deal with all this stuff? Okay, well, some people are going to complain about their job, but is there any objective evidence for those feelings? I think there is. For many years, a workload of about 500 pieces of equipment per technician was a recommended target when planning department needs. A slightly higher figure, taken from a 2004 textbook on clinical engineering, is shown on the far left of this chart. In 2005, a large sample of hospitals was benchmarked in the Journal of Clinical Engineering. That article said the average was 520 devices per technician. It's in line with the recommendations at that time. The next journal I could find that benchmarked a large number of hospitals was Biomedical Instrumentation and Technology, and that was in 2011. The authors said, on average, those hospitals had over 1,100 devices per tech. That's more than double the figure from the 2005 article. Now, in between these two, the chart shows some specific numbers that I found for 1 to a group of 4 hospitals. And it's interesting to see that these numbers seem to follow a trend that's set by the journals, although that could just be a coincidence. On the far right-hand side, this chart shows one response from the 2014 HTM survey. Now, although that needs to be weighed in the context it was given, when you consider it with everything else there, it's hard to argue that tech workload has not increased significantly over the last 10 years. It's at the point now that to follow the recommended practices, the number of people doing this work would need to double. But that kind of increase in the workforce is not likely to happen in the current economic environment. So we still have to meet the expectations for PM completion on an increased number of so-called critical devices. But the workforce to get the job done is not likely to be doubled. So what then? The only thing that can be done about it is to make sure we're using the best tools available for this job. It means upgrading from manual inspection and test methods to task automation. Now, before we jump into task automation, we need to review some basic definitions. Preventive maintenance, or PM, is inspection and test according to a schedule. The concept is to set an inspection interval that balances labor resources with detection of faults that could lead to equipment downtime or an incident. Now, if it was possible, predictive maintenance based on actual usage could reduce the labor. But it's just too difficult to count individual uses, so we rely on fixed intervals, and that makes the planning easier. Requests for corrective maintenance, or CM, occur at random, and they complicate the maintenance planning. CM is combined with PM activity using a priority system. Incoming inspection, or IIN, as I call it here, is testing of performance and safety before the initial use. Now, as we saw earlier, it's not simply good practice. It's required by regulation. Many clinical engineering departments are fortunate to have a computerized maintenance management system that helps planning and monitoring of activities. Inputs to the system are the CM requests, which could be phoned in, but for a modern CMMS, they might come through a web portal. For regulations, preventive maintenance frequencies are set by a manufacturer. Or, alternatively, you can use an AEM program based on a documented risk analysis. The CMMS generates a work order for each piece of equipment and sometimes for groups of equipment. When the work's complete, results from service reports are entered into the system, and thereby the maintenance history for each device is kept up to date. The CMMS provides a number of software modules. I'm only showing two of them here since they're relevant to today's talk. The inventory module has a table for each device in the system, providing fields to store the control number, the make, the model, and so on. The information for a device will include a reference to its PM procedure. Depending on the CMMS, this procedure may be created within the CMMS itself using another software module. Now, per the S&C memo, the inventory module now needs to provide fields with criticality and for AEM program, yes or no. The main job of the maintenance module is to generate work orders based on CM requests and the PM schedule, assigning jobs to techs based on priority. The service history database falls within the scope of the maintenance module. Okay, so this is a schematic that shows the workflow of maintenance activity. If CM involves a major repair, the device must then be tested for performance and safety. That's a regulatory requirement. The IIN process requires testing of performance and of the safety before the initial use, and that's also a regulatory requirement. Therefore, almost all the maintenance activity eventually funnels through an inspection and testing process, which I'm showing here in a red circle. Inspection and test can be based on the manufacturer's procedure, or under AEM, the hospital can develop its own procedure. Typically, the work's documented with a checklist, and best practice says this should be completed while the work is being performed. The checklist forms part of the service documentation or report, which goes back to the CMMS for entry into the equipment history. So here's a picture that shows another way of looking at maintenance activity. It shows that PM, CM, and IIN all overlap in a common set of tasks, which is inspecting, performance testing, electrical safety testing, and documenting the work completed. Because these tasks are done a lot, over and over, it makes sense to see if those tasks can be made as efficient as possible. This shows the basic concept of task automation, which is occurring outside the CMMS. The idea is based on integrating the procedure, which could be either the manufacturer or in-house procedure, checklist, and the service documentation into a single thing. For term, I'm going to call this thing a procedural checklist. To make it easy to use, we could put this on a mobile computing device, such as a smartphone or tablet. Okay, now equipped with our automation tools, the techs are ready to face the challenge of meeting those regulatory requirements. Cool. Fortunately, it wasn't until after I finished writing this presentation I learned that McDreamy Tech here was actually dead. Well, that's really too bad. He must have been overworked. Oh yeah, okay, but seriously, tablets and smartphones are cool technology, but it's not really about that. It's about benefits that come with task-level automation. First, productivity can be increased with a sequenced procedure that provides the necessary work instructions incrementally as they're needed at the moment they're needed. As we'll see in a minute, there's particularly significant increases in productivity associated with work order and service report handling in an automated system. The key feature of an automated system is it's paperless, and it cuts time associated with filling out forms, and it eliminates errors that can happen when inputting information from forms into a CMMS. With automation, consistency is achieved in the work product. Since all technicians are following the same steps and in the same order, the same results are repeatedly attained. There's no need to rely on memory or experience, since the procedure is right there, step by step, in front of you. With automation, less experienced techs can be assigned to the routine PMs, and frees up the senior techs for more difficult CM tasks and team leadership. Since automated PM procedures have pass-fail limits embedded right in them, compliance with standards and manufacturer's requirements is assured. This is important for regulatory compliance. And finally, an automated system records data as each step of an inspection or performance test is completed. Unlike manual approaches to inspection and test, there's no extra effort or labor involved in doing this. It's just an inherent feature of the system. And what you get from it is proof that you've done the whole job and you've done it right. The value of saving records of inspection and test data is controversial. Some hospitals follow the practice of exception-based reporting. This is where all the observations seen during a PM are reduced to one or two summarizing codes, and the detailed PM results are discarded. It's a way of coping with limitations of some systems where the service history has to be input manually from paper records. With automation, limitations around handling and storage of data are not an issue, but that's not really the point. There's always been an interest in trending historical data to develop a predictive model of maintenance rather than one based on schedules. But that's not really the point either. Over time, we've seen an evolution of a maintenance regulation to follow quality system principles applied to industry. For example, the current CMMS regulation requires risk assessment and program evaluation or continual improvement. And these are quality system concepts. This concept of objective evidence of conformance is fundamental to almost any system of quality assurance. When an ISO or an FDA inspector audits a manufacturer, they want to see more than a tick in a box. They want to see the beef. And that is, it's a record of data that shows all required steps of a process have in fact been completed, and they've been completed correctly according to documented specifications. So for some hospitals that are accredited by agencies that follow ISO, those hospitals will need to prove objective evidence of their performance. Some agencies, however, don't follow an ISO standard. Regardless of who accredits a hospital, The federal regulation says maintenance procedures must be strictly followed. A service record that shows completion of each maintenance step and measurements that fall within limits defined by a manufacturer can't be argued with. It's hard evidence your maintenance program really works, and it results in the same or better patient safety than if a manufacturer had done that service for you using their procedures. Now, as regulation of medical device maintenance becomes harmonized with regulation of medical device manufacturing, inevitable that all surveyors will begin looking for objective evidence of your performance. Now, automated systems meet that inevitable requirement now, and they do it without any impact on labor resources whatsoever. This idea of automating PM inspection with what I call a procedural checklist is not new. The basic concept of PM automation was worked out a long time ago. It's almost 25 years now by a company called Dynatech Nevada. What's shown here is a very early version of CMMS software. It's called Sentinel. The software worked with the unit shown on the right, which is called a med tester or a medical device tester. A quarter century ago, there weren't any smartphones or tablets. To run their automation platform, Dynatech created their own computer with a membrane QWERTY keyboard and a 2-line character display. That computer had a then unprecedented 1 megabyte of non-volatile memory. It also had an ECG simulator and an electrical safety tester built into it, but the med tester was meant to be used for a lot more than just safety testing. So this shows how the Sentinel software and the med tester worked together. Each device in the inventory's got a designated PM procedure. The PM procedures are created inside the CMMS by ordering individual tasks into lists that Dynatech called, checklists. Now, according to the PM schedule, a list of equipment, which is due, is loaded into the med tester's memory, along with corresponding PM procedures or checklists. After loading up the data, the technician takes the med tester out of the shop on the PM route. When a piece of equipment is located, the control number on the equipment is scanned with a barcode reader. The med tester searches its memory for a PM procedure that's been assigned to that control number. The technician steps through the maintenance checklist, one step at a time, entering pass, fail, and or data, depending on the step. The checklist can have inspections, performance tests, and safety tests. Safety tests and other tests, such as defib energy, execute automatically as a pre-programmed sequence of measurement steps. Pass, fail, data entry, and the measurements are recorded, and they're saved in the med tester's memory. When the checklist is finished, the med tester produces an inspection label by means of an attached label printer, which is then put on the equipment. When the round of PMs was finished, the tech brought the med tester back into the shop, and they connected to the PC. The completed PM records are uploaded into the CMMS. The open work orders are closed, and the equipment service history updated automatically. There was no need for any paperwork. Now, this shows the details of how checklists created within a CMMS are run on the med tester. On the left is a PM checklist that's been created with the CMMS, and in this case, it's Sentinel. This PM procedure is for a centrifuge. Through the inventory module, this is linked to specific control numbers in the system. When the checklist is run, the tech's guided through the PM, step by step. Some steps you're going to do on any device, and some are specific to a centrifuge, such as repacking the main shaft bearing or testing operation of the brake. At each step, you record that you did it, and you also have the ability to enter a comment or measurement via the data button. As shown here, a limitation of the med tester is its display is only 40 characters wide. It isn't big enough to provide detailed work instructions. So you still have to have your binder of service manuals on hand when you use a med tester. It's either that or try to rely on your memory. The med tester became widely used in U.S. hospitals in the 90s, and it's still used by some organizations today. Over time, some CMMS providers developed interfaces to support the med tester, lines of the original Sentinel program. These are examples of some current CMMS programs that enable the creation and management of checklists like the centrifuge example I showed you previously. These also have the ability to import the service records saved by the med tester, and they can automate the process of closing work orders and updating the equipment inventory with new devices that might be found during department sweeps. In these and other systems, there exists a legacy technology. It's a way of representing PM procedures electronically and assigning these electronic procedures to equipment, and then conveying that information through a protocol to a mobile computer. Equally important, this infrastructure includes a way of representing the maintenance results and protocols for importing those results, which then automates the back-end documentation process associated with work orders and the service history. Okay, well, let's leave behind the technology of the 90s, and we're going to jump ahead to now. Over the last few years, the use of wireless technology and inexpensive mobile computing devices, and in particular tablets, has expanded greatly in the hospital. There's an obvious benefit to medical imaging, where a tablet can be used to replace film. They're being used by nurses to do the charting, to reduce the errors that you can get with paper records. They're also handy just as an internet device for Googling symptoms, side effects of meds, things like that. To support the increasing use of smartphones and tablets in the hospital, the wireless infrastructure needed to support them has also grown. Hospital isn't the only place where the use of mobile computing is growing. Many industries have already adopted mobile computing as an integral component of preventive and corrective maintenance procedures. To meet the increasing demands of maintaining medical equipment, it makes sense to see how an existing automation infrastructure might be improved through these new technologies. I'm happy to say that what I'm going to talk about next is not just some idea or wishful thinking. It's real, and it's currently being used in institutions large and small, and by independent service organizations. This new technology relies on piggybacking on existing CMMS infrastructure, the med tester system, while at the same time expands its capability with a mobile computing device, such as a tablet. It's similar in principle to a med tester, but it's more advanced. Exactly how it works is going to depend on the CMMS that's in use. So here's the first situation. Your CMMS is running on a workstation. In the CMMS, you've got your equipment and your schedule, as usual. And also, you've got your checklist procedures, which are linked to particular control numbers and maybe work order numbers. As you might do for a med tester, you prepare the information to be exported. But instead of a med tester, you export that same data to a tablet. And as shown here, it can be done using Bluetooth, pushing work orders, equipment, and procedures from your workstation onto the tablet. Here's another way. Some CMMS are now cloud-based. The CMMS software resides in the cloud along with your data, which you then access using an internet browser. With some of these systems, a tablet can get the scheduled equipment and their associated procedures through direct communication with the CMMS over the internet. The data comes from the internet to the tablet via a Wi-Fi network. Now, in the event you don't have a Wi-Fi network available to you, another option is to use a 3G wireless service to communicate with you over the internet with your CMMS. Here's another option that enables an older CMMS to make use of current technology. Dropbox is a free service that can be used to sync files across mobile and workstation computers using secure, private, cloud-based storage. You can upload your CMMS exports to your Dropbox account, and the tablet can download them from there. So even with a really old CMMS, like Sentinel, cloud technology enables a supervisor to distribute work to techs who are out of the shop or off-site. Once the tablet's got the equipment and procedures exported by the CMMS, then it's used like a med tester. With the tablet's built-in camera, you scan a barcode on the equipment. An app on the tablet automatically selects the checklist procedure that's been associated with that control number. For some PMs, there might be a safety test, which the tablet can perform by controlling a safety analyzer instrument by Bluetooth. When the PM is complete, a record of everything the tech did saved on a tablet. PM inspection label is printed, which is applied to the equipment. Okay, now this is what a procedural checklist looks like when it's running on the tablet. The example been shown here is for a PM of a defib. Now, doing that PM, the tablet works very much like a med tester. You step through the PM, one step at a time, and you record your work as you're doing it. At the end, you save a record of the PM, and it includes all the data, and then you print an inspection label. Although the tablet emulates a med tester, the big color display and the touch screen makes it a lot easier to see and to use. One of the extensions enabled by the tablet is it could show far more detail in work instructions than a med tester ever could. Another extension that's enabled by an app shown here is limit testing, which wasn't possible on the original med tester. Now in this example, the manufacturer of the defib under test has set a tolerance spec of 10% on the energy. The tech measures the energy with a defib tester, and enters the reading from the analyzer into the tablet. The tablet confirms the value meets the manufacturer's spec and assigns a pass automatically. The tech doesn't need to know the manufacturer's spec or check that the result is in spec, since the tablet does that for him. At the end of the PM, the tablet prompts you to save a service record. Similar to a med tester, at this point, the tech can enter the time he spent working on the PM. The tech's entry will be supplemented with the tablet's own measurements of time. For example, the performance test runtime of the checklist itself. At this stage, an equipment database, which is stored locally on the tablet, is accessed to obtain the next test due date for this equipment. This due date can be changed by the tech if necessary. After the PM record is saved, an inspection label with the equipment control number, the tech's initials, and the next test due date is printed. Now, potentially, a tablet can do a lot more than run checklists that are intended for a med tester. This example shows how it's possible to create your own maintenance procedures using a script language, which is called VPL. When you write your own procedures using VPL, the work instructions can be as detailed as you need. There's no limit to the length or complexity. You've got a range of text styles and fonts available, and you can even show photographs and drawings that you've scanned from manufacturer's service manual. You can also play videos, which you can film yourself using the tablet's video camera. Maintenance procedures you've written in VPL can be launched by med tester checklists that are created inside a CMMS. And that's how the tablet's full capability can be leveraged by a CMMS, even though the CMMS only understands a med tester. When all the PMs are complete, the service records can be returned to the CMMS through any of the means I talked about earlier. Again, the particular method will depend on the CMMS that you're using. Similar to a system that works with a med tester, the CMMS may have the ability to close open work orders and update the equipment inventory automatically. As with the original med tester Sentinel system, there is no paperwork involved. So back a couple of slides, I showed that what a procedural checklist looks like when it executes on the tablet, and I showed how it's possible for a checklist to include scanned pages from a manufacturer's service manual or even video. Now, where does a procedure like that come from? We've developed a design tool that clinical engineers and senior techs can use to simplify the creation of the manufacturer equivalent PM procedures. And this tool, which runs on Microsoft Windows and it's currently in beta testing now, is called an Integrated Development Environment, or IDE. Maintenance procedures created in this IDE can be deployed to the tablets by USB, Bluetooth, or through the internet by Dropbox. What's been shown here is a screenshot of the tool. On the left, there's a library of generic PM procedures for a wide range of medical equipment, ranging from anesthesia unit to Whirlpool. The panel in the middle is a document editor for the VPL script, and in this case, it's for the PM of an anesthesia ventilator. You can open up a generic procedure, and you can change or add inspections, tests, and maintenance steps that you've gotten from the manufacturer's PM procedure. You just type them in using plain English. On the right-hand side, you can see how a step's going to look on the tablet. And alternatively, the tool allows you to use the graphical editor on the right-hand side to edit the procedural steps. Now, to test the script, the tool launches a tablet emulator. Now, that allows you to run the PM on your PC, and you can see how it's going to work before you deploy it to the team. Security issues in computer assistance maintenance revolve around traceability of procedures and records for accreditation and around data integrity. CMMS regulation requires AEM procedures to be strictly followed. Once a maintenance procedure has been set by a designated person or a group, subsequent changes by unidentified persons can't be allowed, regardless of whether those changes are made by marking up paper documents or by editing a procedure with a word processor on a computer. Service records in electronic form can be vulnerable to deletion or tampering, either intentionally or more likely by accident. Fictitious service reports can be easily fabricated on a computer. That's a concern for some institutions which rely entirely on outside contractors for their maintenance. A system which completely separates the management tools from the productivity tools is easier to make secure. An example of this kind of system is like the one I've been talking about. Using a CMMS or an IDE, the person responsible for procedures uses software tools which are accessible only to them by means of their workstation login. And procedures are deployed from the management side onto the mobile devices in such a way that it prevents the technical staff from making unauthorized changes. Service records can be stored on a mobile device behind a security wall, preventing unintentional or intentional modification by the device users. However, when the service records leave the mobile device, then they become vulnerable again. To overcome that problem, service records can be encrypted for delivery to the service manager or customer. The manager or the customer owns the key which decrypts the records, thus ensuring that the work product received has not been tampered with. Mobile devices based on Google Android can be effectively secured through a special software application known as a custom launcher. An example of a security app for an Android mobile device is shown here. The security app acts as a locked door through which a user must pass to gain access to the functionality of the device. That means that an administrator can configure password access for all software and all functions that are installed on the device. For example, by setting up a password on the internet browser, an administrator can block a user from accessing unauthorized websites and downloading potentially malicious apps and files. Access to general-purpose file managers, word processors, and text editors can be similarly blocked to guarantee security of the maintenance procedures and service records which are stored on the device. Securely stored maintenance records are encrypted with a private key before delivery to the maintenance supervisor or the customer, so that records cannot be tampered with while they're in transit. 4 levels of security are provided by this system so that access to software programs and device features can be fine-tuned by an administrator to suit the responsibility and job function of both senior and junior technical staff. Rather than a general-purpose approach, this is a security system that's been designed with the needs of maintenance in mind. Okay, well, so far I've been talking about maintenance automation. That's the automation of the maintenance workflow. That includes the service documentation. An essential part of that workflow is equipment's performance testing and safety testing. Many PMs are going to involve testing of equipment to ensure it's both safe and it functions in accordance with manufacturer specifications. Now, as you saw earlier, that's a regulatory requirement. Since testing can consume a lot of time, there's a significant increase in productivity that can be achieved by automating these tests. Okay, now the basic principle of automated testing is similar to automated PM inspection. A test is broken down into a list of individual measurements which are performed sequentially by an analyzer instrument. And depending on the test, the measurement sequence could be executed with complete independence by the analyzer, or it could be done with assistance from the technician who's following instructions that are displayed by the analyzer. An important aspect of a test is acceptance criteria, or pass-fail limits, which may be defined in a standard, or they might be from the manufacturer of the equipment under test. Each time the analyzer acquires a reading, the analyzer compares it to a pass-fail limit defined in the test program. At the end of the test, the analyzer reviews the individual results and it assigns an overall pass or fail to the test. There are some analyzers that provide means for documenting the test results. In a maintenance automation system, those results remain in electronic form, and they can be incorporated into the service report or the checklist for PM inspection, which is then forwarded to the CMMS. Now, because testing requirements for medical equipment can't be easily met solely with multimeters, oscilloscopes, and function generators, there's specialized instruments that exist for checking defibrillators, incubators, infusion pumps, and other medical equipment. Simulators are specialized function generators used in testing patient monitoring systems. Electrical safety testers are used to confirm that mains-connected equipment will not injure patients or staff through electric shock. Test equipment manufacturers take different approaches to automated testing. The instruments shown in this slide all provide built-in test automation as part of their operating software or firmware. An alternative approach uses a computer, such as a laptop, and that needs special software that controls the instruments through wired connections. The med tester of 25 years ago could also provide test automation through its procedural checklists. By writing a suitable checklist in a CMMS, it became possible for the med tester to control up to 8 test instruments connected to it by RS-232 serial cable. The med tester could control patient simulators, and it could read analyzer measurements that would be integrated with the results of inspections that were done during a PM. PM results, and including the performance tests, would then be uploaded into a CMMS to automatically close open work orders, like I said previously. Now, given that was done, over 20 years ago, that was an advanced concept for its day. But more importantly, this was an open system that techs could make work with the test equipment from any manufacturer, provided the test equipment could be controlled from an RS-232 serial port. Okay, today, by following the open system approach of the med tester, it becomes possible to integrate performance and electrical safety testing with PM inspection, and thus automate the entire process of preventive maintenance from opening to closing of a work order. This open system approach acknowledges that most biomed shops and service organizations will have acquired test equipment from different companies over a number of years, and they will likely acquire some new test equipment in the future based on value and benefits, regardless of the brand. An automation system that can be made to work with different makes of test equipment, like the original med tester could, delivers the greatest value. Okay, so I'm going to go briefly over what I've been talking about. We looked at the issue of increasing workload, and we saw the feelings of professionals working in the field are supported by a trend that can be drawn from academic and other literature. Current regulations are not going to reduce the workload, and if anything, the expectation of 100% PM completion on a broader definition of a critical equipment is likely going to cause current workloads to be increased. It's unlikely the workforce is going to be doubled anytime soon. The only way to cope with this is to increase efficiency and make the best use of the people available. And that can be done by using the right tools for the job. Automation saves time, money, and manpower. A CMMS automates the management function only. Task automation takes what a CMMS does to the next level. It expands the automation level of individual work instructions, inspections, and test measurements. As a result, improvements are gained in productivity and consistency of work product. A system for task automation was developed a quarter of a century ago, and it's still supported today by many CMMS. As we've seen, the MedTester's legacy can be improved and extended through the use of mobile computing devices and wireless connectivity. The tablet-based system you've seen in this presentation is called the VPad or VPad. Mobile computing devices like today's VPad enable a maintenance automation solution, and it's affordable and which is scalable through installable apps. It interfaces with many CMMS systems, but it can also provide PM task automation without any support from a CMMS. VPad adapts to match the specific needs of hospitals and service organizations, large and small. Now, before I finish off, I'd like to leave you with a couple of thoughts. The first one is, what is old is new again. Second, make sure you use the right tool for the job. Thanks for listening.
Thank you so much for that fantastic presentation, Mark. We have a bunch of questions here that people are very interested in getting answered, so we're going to get right to it. Question one, you've been talking about automation with a CMMS system. What if you do not have a CMMS or have a CMMS, but it doesn't work with the MedTester?
Okay, John, that's a valid question. You know, not everybody's got a CMMS, and although some CMMS can work with the MedTester, you do need a special software module for that to make that happen. So I think what I'd like to do here is, oh, excuse me, sorry about that. Let's go back to a slide I had that I think it's this one. Okay. So what this is showing right now is the app that does the PM inspection part of the procedure. Like, this is the actual PM inspection going on here. This is what we call VPad check. And although this can work with a CMMS, what you can do with this app actually comes with its own PM procedures. And so the app provides a menu that you can select a PM procedure from, and you can then work through that. Alternatively, you can create your own procedures like this and install these procedures on the tablet, and they will then be usable to you. So you don't necessarily need a CMMS to create procedures. You can use these apps independently on their own. Now, for those of you who don't have a CMMS, we also have another solution, which is an equipment management app, and we call that app VPad EQM. And with that app, you can input an equipment inventory and then link the inventory to procedures that are in the VPad check app. And so with that system, you have a very simple equipment management system there. You can create work orders, there's a schedule, and that kind of thing. So that's suitable for those who don't have a CMMS available to them.
Okay, great. Another question here. I was on your website, and I see a lot of analyzers, but nothing for ESUs. What ESU tester will work with the systems you discussed?
Okay, well, you know what? I'll just hop over to this slide I showed earlier. Okay, so like I was talking about earlier, what we have the ability to control other types of test instruments, and provided that the tester has some kind of serial communication capability. Like, for example, RS-232 port or USB port or Bluetooth. We have the ability to interface with that and make that work one way or the other. So we tend to work with the customers on developing that solution. But I guess the question is, like, what if I don't have any ESU analyzer? Well, I'm happy to say that Datran will be releasing a new product to the market. It's our new ESU tester. Call it the VPad RF, and you'll be able to actually see this at the upcoming MD Expo show. It's coming up in a couple of weeks' time at Las Vegas. Now, this is a very compact test analyzer. It's got a lot of great features in it. It's got built-in test automation. It's got a built-in digital oscilloscope. It's got a built-in RF spectrum analyzer. It's all built into the same analyzer unit. We're really quite proud of this new product, and it's a breakthrough for us. And you'll actually be able to see this thing at the MD Expo show coming up in Las Vegas.
We appreciate that quick little plug-in. Of course, there's going to be lots of new technology and products at the MD Expo in Vegas, and this is just going to be one of the many great innovations out there. Next question. Why are we still performing electrical safety tests anyway?
Why are we performing electrical safety tests? You know, that's another one of these hot button issues. You know, it's kind of like exception-based reporting. You know, the issue is there is, you know, why we keep doing these things on PMs. You know, nothing ever fails. It just seems like a big waste of time. So let's just back up and we'll start here. You know, we have to do electrical safety testing when we need to be 100% certain the equipment is safe. So when's that? Well, if you're doing a repair and you've disassembled a piece of equipment and you're going to put it back together, you know, connecting up cables and so on, then you really do need to do an electrical safety test there. You need to do electrical safety test when you've got a new piece of equipment coming in for the first time. You don't even know anything about it yet, so you need to do safety testing there. That's not just good practice, that's the regulations. You have to do it then. I guess the question is coming from, you know, routine electrical safety testing, PM inspection, and particularly, you know, doing routine electrical safety testing on non-critical equipment, like, you know, for example, examination lamp or something like that. Well, the answer to address that is you should do your test according to a safety standard that's specifically intended for routine PM inspections. And this would be a standard that's been approved by a recognized standards body. I'm thinking of something like IEC 62353 or NFPA 99. Now, the advantage of testing to a standard like 62353 or NFPA 99, which is for the states, is that the number of measurements that you have to finish is greatly reduced compared to a product approval standard, like, for example, 60601. So when you combine the right standard with test automation, the testing time, even some of the most complicated medical equipment, it falls right down to just like a couple, 1, 2, 3 minutes. So that's the solution there. It really, at that point, if you use the right standard, combine it with test automation, the effect on PM workload is no, I would say it's inconsequential, but it's greatly reduced. So and that's why on the VPad we have these automation apps for those particular types of standards, what we call recurrent testing in preventative maintenance. We have the A3 app. We also have the NFPA 99 app for VPad automation.
Great answer. Next one. What is the time savings for a tech using VPad versus manual?
Well, I mean, it really is quite dependent on what particular task the biomed has been doing. Now, if you've been doing things with a manual safety analyzer, and then after that, and you're actually following a proper standard, you know, you're following NFPA or you're following an IEC standard, and then you have to enter the data from that into a CMMS program from a handwritten record. Well, I mean, if you're going to eliminate all that stuff, I mean, you could save up to maybe 50%. You just think about all that kind of busy work effort. And as I said, the automated system, the principle there is to you know, minimize that kind of paperwork as much as possible, and just, you know, and some circumstances, the automation. I'm thinking about things, automation of tests that require quite a long time. That would be incubator testing. In case of infusion pumps, there's another example where tests may require a number of minutes. I mean, that's an opportunity to allow the tester to just kind of do its thing, and then you can multitask and go and deal with emails or whatever else might be on your plate for that day. So there you go. That's some examples of how that would save time.
Okay. Next question. How many procedures does the VPad hold?
Well, this is the thing about procedures. Fortunately, they're documents. Now we can actually go into procedures that are based on video. We can go there. We have the capability to do that. But for the most part, procedures are documents. And VPad's got about 12 gigabytes of available memory, and we can expand that with SIM cards, SD cards, up to 32 gigabytes. The procedures are relatively small, yeah. So practically speaking, if you think about that, the number of procedures you could store on the tablet is just virtually unlimited.
Okay, thank you. Next question. Where can we obtain the procedures?
Wow, that is a really good question. That's a really good question about what procedures should be used and so on, where are we going to get them. Now, the VPad automation app, it comes with about 100 example PM procedures, and you can use those as templates to start with. If you're using a CMMS program, then that program usually comes with a default set of PM procedures. And particularly speaking, if the institution has been using the med tester for a number of years, there'll be a huge infrastructure of PM type procedures already there that can be downloaded in the tablet and used. However, I'm acknowledging that question as, it is an issue about where do PM procedures come from, and who's got the authority and so on. And it's a very another one of these hot button topics, and I don't really want to necessarily open up discussion at this point to that. But the discussion is out there, and I think, if I may do so, offer an opinion about the need to kind of get together on this as a community and establish a group there to kind of organize this and get this to happen, because sometimes the manufacturer's procedures are not easily gotten. Anyway, I'm going to cut it there, and maybe we've got time for a couple more questions.
We sure do. Next question. Can the VPad test non-biomedical equipment? Sure.
Oh, yeah. I mean, the VPad's capability can be applied to almost any sort of device. The concept of PM, preventive maintenance, isn't exclusive to medical devices. Like, for example, if you go back to one of those slides I showed you earlier, in industry, here, I mean, all kinds of industries are doing preventive maintenance, and a VPad, the concept of how the VPad works can be applied virtually anywhere. I'm thinking there that the participant is thinking about, well, can we use the VPad to do inspection of facilities, maintenance, that type of thing? And I would say definitely yes, we can.
Okay, next question. Can you print or save the PM results as a PDF document?
Yes, we can do that. We have an app on the tablet, which is called the Record Manager. Now, I talked about the equipment manager that we have app. That's the inventory side of things, but we also have another app for management of the service records. And this app allows all different ways of handling those records. We can print to Bluetooth printer, or we can print to wireless printers. We can print to printers that are visible over the internet. We also can convert our service report from the native format on the tablet to PDF document. You can insert, if you're an ISO, you can attach an image of your corporate logo to our service reports. You can insert a signature, a digital signature into our reports. This is all done with our record management app on the tablet.
Okay, next question. Is the inventory app multi-site?
Well, it wasn't. I'm going to be very clear about what that app is. You know, a smartphone app is not going to replace a full-blown CMMS system like some of the ones I showed there, right? You know, this app wasn't designed to be multi-site, but facilities are identified in that app, and the list could be sorted accordingly.
Okay, I think that's going to about wrap up the question and answer period. We want to, in closing, thank you, Mark, so much for your presentation and being today's sponsor, Datren Systems. Please visit their website, datren.com, to learn more about their products and services. That's DATREND.com. And attendees, remember, to obtain your certificate of attendance, you must complete the post-webinar survey at the conclusion of today's presentation. This survey will appear shortly on your computer screen, and if you do not receive the email survey, please email us at webinar@mdpublishing.com. Please visit onetaknation.com/webinars to register